Hello, we are on page number 9 of our pink note packet on absolute value, and we are going to talk about absolute value inequalities. Specifically, when do we use and versus when do we use or? So, a couple steps for solving. The very first thing we're going to always do every single time is we're going to be sure that we isolate the absolute value. That is the same as when we solve an equal sign problem. We want the absolute value to be alone because once it's alone, then we can unlock it. And in order to unlock it, we're going to talk about what's inside the absolute value and write two, in this case, inequalities using it. So for questions that are less than, we think less than, and here's what we do. We take whatever's inside the absolute value, and we write an inequality that shows that we can be less than that number. And then we write a second inequality that shows we can be greater than the negative of that number. And we put the word and in between those two inequalities for less than. For greater than, I think greater, and the way I write my inequalities is I do one that's normal, and then I do one that represents the negative side. And I put the word or between them. Okay. What we're doing here is we're doing what I call a switch and flip. I switch my inequality to point the other way, and I flip it to being negative. And what I mean by that is we have, just like when we did equations and we had to represent the positive side and the negative side, we have to do the same thing here. We have to account for being away from zero on the positive side and on the negative side. And we represent that a little bit with our inequalities and pointing them various directions. Once we've written both, we solve and graph. And just a little detail, if you are doing an and, remember to write the sandwich. I realize that's a weird phrasing, but I'll show you what I mean when we get to one of those problems. It's really only a thing for a delta math situation. So let's take a look at this first question. We have an absolute value that's totally alone, and so we are ready to do the next step and unlock it. And when we do that, we use whatever's inside the absolute value twice. So in this case, r, this r right here, inside our absolute value is going to form one side of our inequalities. So r is less than or equal to 3, and then switch and flip. Switch your inequality to point the other way, flip your positive 3 to a negative 3. This is a less than, so we write and. And then it's time to graph it. So here's negative 3, and we are going to be greater than. Here's positive 3, and we're less than, and they meet back in the middle. Because it says to write that cute little sandwich, our sandwich would look something like this. Negative 3 is less than or equal to r is less than or equal to 3. Again, that's a bigger deal in a delta math problem where it says, hey, we got to write it this way. They want to see it written like that because that's technically the formal convention. Let's look at the next one. Check to see is your absolute value alone. Yep, totally alone. Nothing else is on that side. I'm ready to use what's inside there and unlock my absolute value. When I unlock it, that p minus 8 on the inside, the first inequality is that it's greater than 2. The second inequality is that it's less than. Switch and flip. Now we can solve both parts. So either P can be a number greater than 10 or P can be a number less than 6 to make the original thing true. I forgot something. We need the or. Or, because this is a greater question. And on a greater question or greater, you'll notice that your arrows are going away from each other, which is another great way to check it out. Okay, very last one. This one's got a lot more going on. If you notice, your absolute value is not alone yet. We need to isolate it. So we're going to add 9 to both sides. And then we do not distribute into absolute value. Let's write that. Do not. Instead, divide. And so we cannot bring that -6 in. What we do is we're just going to divide both sides by -6, which is a great opportunity to remind ourselves that we need to be careful when we divide to still flip our inequalities, because that's any inequality that we ever do. Now let's check out where we're at. We've got our absolute value alone. It's the only thing on its part of the equation. We are going to unlock it and set the 9v minus 2 free. When we unlock it, 9v minus 2 is greater than 7. 9v minus 2 is less than -7. This became an OR problem, and we could continue solving it, but I'm going to pause us. 1, because I'm out of room. 2, we've solved a lot. 3, it gets into some decimals. 4, I think you got this. If you need me to, please let me know. Otherwise, I am hopeful that some of this is starting to make sense. As always, ask questions in places you're stuck.